Hey everybody, this is Kevin, and I wanted to do a quick little video on my latest project, which probably most of you don't know about because I didn't do a build on this, but I do want to show you the completion and what the plans are for it. As you know, I do a lot of flight testing with my RAV series of rockets, and most recently I've been flying the RAV-5, which has undergone some incidents, we'll say, but it's been rebuilt and it's okay. But I wanted to attempt something new, so that required a new rocket, so I decided to build the RAV-6. Now, most of you may not realize, but all of my RAV series of rockets, starting back in RAV-1, 2, 3, 4, and 5, and now RAV-6, have all been built from the ESAM-58 kits. The biggest difference you'll probably notice is on all previous rockets, I left off the bottom fins, and I simply moved the main fins back to the bottom. And then I used these fins on any boosters that I would run. For example, here's the F booster that I've been running on the RAV-5, and those are the fins that would normally go right there. So on this kit, I wanted to try to increase my stability by building the rocket stock, the way Estes designed it, running both sets of fins per plan. Now, I also, for obvious reasons, want to do some testing with the ACE unit and air start. So I need more power than the standard C motor that, you know, would go in it. So I did upgrade it to an E, just like I've done in the past. But you'll notice that there's a line right here, and you might see these little screws right here. So what's that all about? So if you want to fly it stock like an ESAM-58 would normally be, you'd fly it in this configuration. This is the full length tube right here, 18-inch. But I cut the tube in half, making this part removable, so then I could install the new ACE unit. Now I'll tell you a little bit about the ACE while I remove the bottom portion from the top. So just a couple, actually these are RC servo screws that I used to connect the top and the bottom. And believe it or not, the paint that you see here, the gray, is simple Rust-Oleum gray primer. I just primed it, decaled it, and then clear coated it, and the primer looks pretty darn good just as it is. So when you remove those two screws, now suddenly this becomes detachable through a coupler. And inside the coupler, I have glued in a plastic ring, which you can kind of see around here, which gives the screw more purchase power into that to hold the screw in place. Now, in order to remove this part completely, I will need to, and I probably should have done this first, is disconnect the nose cone. So let me go ahead and do that. We'll remove it. Okay. That way we can feed the line out the tube and remove this completely. And then we can go ahead and run the ACE. So let me shove all this in where it would go if I'm running the ACE. And there's something new I want to show you about the ACE as well. This is all new design here. So here's the new ACE. Well, before I plug it in, let me show it off to you. So you notice it's painted exactly the same as the cardboard tube, because this is a new material. We've gone from nylon plastic now to ABS plastic. And ABS takes paint, you know, equally well as nylon, but it just seems to take really well to the paint and the decals. Those are standard water slide decals and paint on ABS plastic. And overall, I will tell you too, this came out 4 grams lighter than the nylon. So you're a little bit of savings in weight, and I think it just looks better. It's more manageable. Like I said, you can customize it, paint it to match your rocket colors. That gray you see right there is the actual gray that it came printed, but then I just painted the clear. The interior is the same, with the slight exception up front. The cylinder now is more freewheeling. It doesn't have any shroud over top of it, so this less hang-ups on this, so you'll get better spinning action out of the motor. Obviously you can see there's no parachute in there just yet, but that will change. Okay, but the operation's the same. So to run this now, you would just, let me pull out my little Kevlar ring, attach that. Slide the ace in. Okay, now I'm gonna insert the nose cone, and I'm going to move this out of the way and lay the rocket down and show you more what it looks like in its full configuration. So now it looks just like the ESAM did, you know, in its traditional sense, but now it's got the ace unit. Now when you're running the ace, if you don't want to run the backup, you can simply screw these holes in if you want to screw it in. But if you want to run the backup, you just leave that open. You might want to plug the vent holes so that any gas release will be forcing the bottom half off. But that's up to you on what kind of configuration you want to run. But there's some options there. Okay, now the next question, how are you going to air start this thing? Well, in times past, specifically the RAV-5, I ran a brass conduit through a, well actually it was down here. I ran a brass conduit tubing inside the rocket through a baffle, which then led out to the motor. Now, I'm saving a lot of weight on this rocket because I'm not using a baffle, and instead of using that heavy brass rod, I've resorted to using a polystyrene plastic rod on the outside that actually is right next to the launch lugs. So it actually, you know, it looks appropriate. It's like you don't even realize what it is or why it's even there, but you might be able to see this little tube right here. So what it's going to do is the wiring from the air start starts up here in this cargo bay, up where the RFC is and all the other electronics. The wire from the air start will pass through the ace, come out the bottom of the ace, and then pass through one of these vent holes. Let's see if I can hold it closer for you. So it's going to pass through out one of these vent holes, then it's going to travel down this conduit out to the bottom. Knocking things over here. Out to the bottom, and once it comes out the tube, it'll go down into the body tube and run alongside the motor mount up inside there. And then those wires will simply clip on to the igniter that's in the bottom stage or upper stage. So just like before, I'll be running an F motor with a standard igniter that plugs in there. So that'll be our booster. It burns out, the RFC recognizes it, sends a signal through the wire to the battery to power the second motor, which will then dislodge the bottom booster, which parachutes down on its own, and the rest of the rocket continues up to apogee. So that's, in a nutshell, what this whole new project is. It's a lighter, I think more robust system, running a better, in my opinion, a better looking ace unit, because now we can customize it, paint it, decal it, and it just, you know, blends right into the original look of the rocket. So I'm really excited about this. I'm going to do a couple test flights in its standard configuration, and then some ace testing. And then once all that proves to be successful, then we will then move on to the booster flights for air start. But anyway, that was just a quick little tutorial on my new RAV-6, also known as the ESAM-58. And one thing I'm going to point out too, I didn't notice, or I didn't mention this earlier, the ESAM comes with these decals that has a serial number, and that means whatever it means. I have no idea. But I did include some new decals on this ESAM. When I'm running the ACE unit, it says RAV-6 ATV3. Of course, we know the RAV stands for RFC ACE vehicle, and this is the 6th variation. But it's also the 3rd rocket that I've done testing with the Air Start. So this is my Air Start test vehicle number 3. So a lot of designations for one rocket. ESAM-58, RAV-6, ATV3, all in one unit. So there you have it. You'll be seeing this out at the flying field very, very soon, and we'll get some launches on it. So thanks for watching, everybody. God bless, and we'll see you on the next one.